Concentration of solution. Chapter Solution, Class 12. Subject, Physical Chemistry. Physical Chemistry. In the previous video, I discussed what a solution is. Now comes the most important tool of this chapter, concentration term. Because every question in colligative properties, vapor pressure, osmosis, Raoult's law, freezing point depression, elevation of boiling point, all of them depend on one thing: how much solution is present, how much solute is present in the solution. And for that, we must master molarity, molality, mole fraction, and interconversion of concentration terms. Today, we will solve JEE standard numericals on each term. Let us start with molarity. First, molarity. Molarity is expressed by capital M. Its definition is the number of moles of solute present per liter solution is called molarity of solution. Mathematically, capital M, that is molarity, is equal to number of moles of solute by volume of solution in liter. Its unit of molarity should be mole per liter. Important points for JEE examination or NEET examinations: molarity depends on temperature. Important point for examination: molarity depends on temperature. Why? Answer is because volume changes with temperature. Volume changes with temperature. If temperature increases, volume increases. Molarity decreases. That is why molarity is not preferred in qualitative properties. Let us take one example as numerical question. Number 1, 11.7 gram NaCl is dissolved to make 500 milliliter solution. Find molarity of solution. To answer this question, first, step 1, number of moles of solute, that is NaCl, is equal to 11.7 by 58.5, because molar mass of NaCl is 58.5, and on division we will get 0.2 moles. Step 2, volume of solution in milliliter, or it is given in milliliter, so just solve it, convert it into liter. It should be equal to 500 by 1000, and this is 0.5 liter. Now, what will be the molarity? Molarity will be equal to 0.2 divided by 0.5, and then the value will be 0.4. This is the molarity, 0.4 molarity. That means the answer is 0.4. Just discuss another question. Question number 2. If 10 gram glucose is dissolved in water to prepare 250 milliliter solution. If density of solution is 1.2 gram per milliliter, find the molarity of solution. Here in this case, density is used as extra information. In JEE, sometimes extra data is given to confuse you. To solve this question, you need only two things: number of moles of glucose, that is solute, and this should be equal to 10 by 180, because molar mass of glucose is 180. So 10 by 180, the value will be 556 mole. Volume of solution in liter, it should be equal to 250 by 1000, and it is equal to 0.25 liter. Then molarity of this solution is 0.556 divided by 0.25, and the answer is 0.222. Here is the answer. So by solving these two questions, we came to know what is molarity and how should we solve the question of molarity. Now come to the molality. This term is expressed by small m. It is defined as molality is the number of moles of solute dissolved per kg per kilogram of solvent. Therefore, mathematically, molality should be given as number of moles of solute by mass of solvent in kilogram kg. Unit of molality mole per kg. Why molality is preferred in solution chapter? Because mass does not change with temperature. So molality is temperature independent, and colligative properties depend on number of particles, not on volume. Once again, because mass does not change with temperature, so molality is temperature independent, and colligative properties depend on number of particles, not on volume. That's why molality is preferred in this chapter, that means in solution chapter. Now I'm going to discuss numerical regarding molality of JEE standard. Question number 3. 20 gram NaOH is dissolved in 200 gram of water. Calculate molality of solution. We should take the step. First, determine the number of moles of NaOH, that is solute NaOH, which has molar mass 40. So it should be 20 divided by 40, and the value should be equal to 0.5 mole. Then calculate mass of solvent, that is water, in kilogram, and for that the value should be 200 divided by 1000. It should be 0.2 kg. Now you can put these two values into molality formula. So molality 0.5 divided by 0.2, the value is 2.5 molal. That means answer is 2.5 molal. Let us discuss question number 4. 5 gram urea. 5 gram urea. It is also solid. 5 gram urea. Molar mass of urea. Molar mass of urea is equal to 60 gram per mole. Is dissolved in 100 gram water. Okay, find molality. So start the steps to answer the above question. So number of moles of urea, that is solute, is equal to 5 by 60, and the answer should be 0.0833. Mass of water in kilogram, it should be equal to 100 by 1000. So it should be 0.1. Now molality should be equal to 0.0833 divided by 0.1. Value should be equal to 0.833 molal. Let us discuss third term, that is mole fraction. Mole fraction. Mole fraction is expressed by X. Definition of mole fraction should be the part of moles of a component per mole of solution or mixture is mole fraction of that component. Suppose a solution contains a mole and a number of moles of component A and B number of moles of component B. Then mole fraction of A, that should be written as XA, is equal to mole of component A by total mole of solution. Mole fraction is unitless. Mole fraction is unitless. And second important point, sum of mole fractions of all components in a solution is equal to 1. That means XA plus XB is equal to 1, where XA mole fraction of A and XB mole fraction of component B. Important question. regarding mole fraction. Suppose 5 gram urea, as we know, molar mass 60 gram per mole is dissolved in 100 gram of water to prepare a solution. Calculate mole fraction of urea in solution. So answer should be step 1, number of moles of urea is equal to 5 by 60, that is equal to 0.0833. And step 2, number of moles of water, it should be equal to 100 by 18, because gram molar mass of water is 18, so the value should be equal to 5.55 mole. Now sum total mole of solution should be equal to number of mole of urea plus number of moles of water equal to 0.0833 plus 5.55. The value is equal to 5.633. So mole fraction of urea, that is X urea, is equal to mole of urea, that is 0.0833 by 5.633. The answer should be equal to 0.0148, and mole fraction of water may be determined as 1 minus 0.0148, and it is equal to 0.9852. So you can calculate the mole fraction of all the component by calculating one of the component. Now interconversion of concentration. There is a very important topic, that how can we correlate the molarity to molality. So interconversion of concentration terms. That means relation between molality, let us write it, relation between molarity and molality of a solution. So the relation is molality बराबर 1000 into molarity divided by 1000 into density of solution minus molarity of solution into molar mass of solute. Molar mass of solute, let it be W1, where small m molality, capital M molarity, D density of solution and W1 molar mass of solute in solution. Let us take one question regarding this relation. So convert 2 molar H2SO4 solution density of solution 1.2 gram per milliliter to molality. To answer this question, we know capital M to D 1.2 W1, that is molar mass of H2SO4, molar mass of H2SO4, and it is equal to 98 gram per mole, 98 gram per mole. So we can determine the molality by putting the value into formula. 1000 into 2 divided by 1000 into 1.2 minus 2 into 98, and the answer is 1.99992. What is summary of today's discussion? Summary. Today we learned molarity, molality, mole fraction, interconversion of molarity into molality. Remember, in colligative property, molality and mole fraction are more useful, and in next video I shall use these concentration terms in Raoult's law, vapor pressure lowering, relative lowering of vapor pressure, and you will see how today's mathematical questions becomes very powerful tools if you understand this video.